Ojani, Monica, Progress, and Allison. That exercise that we were dealing with. Remember, I asked you to find a 0 above 1 in the third row and 0 in the first row. And then I asked you to find 0 in the first row above 0 in the second row. That was my request. What did you get the matrix to be? The final one.
I have 1, 0, 0, and then 3.
Hang on slowly. I need to be able to write it down so that I can compare it with mine. You have got 1, 0, 0. Yes.
And then 3.
3.
And the next row is 0, 1, 0, 1. And the last row, 0, 0, 1, 2.
Is
Yes,
based on the solution that we already found before writing this matrix in identity form the way it is. Is there any difference from the solution that we found and the one that we are having currently in this matrix?
No.
No. I agree with you. No. Because x1 is 3, x2 is 1, and x3 is 2.
Yes, sir.
Thank you. Now we are done with what we were busy with a few weeks ago. Now let's get started with now session. Yesterday we dealt with this exercise. Do we agree? Or am I not telling the truth?
No, we did do this yesterday.
Which one?
We did both of them.
We did both of them.
Yes.
And did we have the answers for both of them?
Yes.
Thank you. Now, did we do this one?
No.
Okay. Now, as part of testing your understanding of solving systems of linear equations, can I request you to solve this system? Anyone who has got a challenge or who doesn't understand anything that I've spoken about since the beginning on Monday up to so far?
I don't understand how you got the answers. I don't know how you got there. I'm struggling. I've been trying to do the exercises you gave us yesterday, but I didn't get the answers that you guys got. I get the different answers. I don't know what I'm doing wrong.
Yesterday's exercise, which one specifically?
I did exercise B. But
exercise
B.
B.
Yes.
B, this one.
Yeah.
You see my screen?
Yes, I can.
This one.
Yes.
What did you get?
Yeah. Like that totally. Oh. My x1 is -1/2, x2 is -4, x3 is 1. So I don't know what I was doing wrong.
Okay, hang on. What did you? That's Magwena, ne?
Yes.
Okay. You said your x1 is what? What is your x1?
My x1 is -1/2, x2 is -4, x3 is 1, +1.
Magwena?
Yes.
You need to be careful the way you are driving. Otherwise, you will end up causing accidents. What is the value of x1? Your value of x1 is minus a half.
Yes.
X2?
-4.
-4.
Yes.
And then x3?
1.
+1.
Yes.
Yes.
Hello.
Lebogang,
Yes. A.
have you got our answers?
Yes, I have the answers.
Did you get them? What did you get?
For x1, I got 11/12. X2 -71/12. X3 -5/12.
I thank you. Okay, then the answer for number B, which a number of people found. I remember who else? Nobile found it, as well as Sibusiso. These are the two people that I can remember who got what we were looking for. X1 to be 11/12, X2 to be -71/12, and X3 to be -5/12. I thank you again. Now, using the very same technique that we have been using that we use to solve those other systems of equations, let me request you to solve this system. Let me give you 3 minutes to solve this system.
Yesterday you said these kind of problems that are overdetermined have infinity solutions.
Thank you. I will come back to you, Lerado, to refine what you just said. But ideally, that is what we are saying.
So can I please ask a question?
Oh, yes, Gnaido.
How do you prove that it has infinitely many solutions?
Now, Abdul, from the system of equations, what is your matrix?
It's 1, 2.
Sorry?
1.
Slowly.
The first one
1.
is 2, 0, -1, 1, and 1. That's the first row.
Yes, yes. Second row.
Second row is 0, 3, 1, 0, -1, and 2.
Thank you. The last
And
row.
then last row is 0, 0, 1, 7, 0, 1.
Thank you. Now, what is the problem? Why are you moving around? Why are you moving around in circles?
So maybe there's something, a row operation that I'm not doing correctly, or something that's causing me to be moving in circles. I'm not sure, Minion.
No. In this case, let's talk. Okay? Everybody, let's talk. How do we solve a system of equations? How did I say we solve a system of equations? What is the leading coefficient in this matrix?
1.
1.
In order
It's
to
1.
solve a system is 1, I agree. In order to solve a system of equations, what is it that you need to do?
Leading ones. To create the leading ones.
You create the leading ones. Is that what I said? That's not what I said. Spusiso, your hand is up.
Okay, so I think it's creating ones in a diagonal form.
That's not what I said.
the entries under the main diagonal have to be 0.
I hear, is that Kineidwe?
Yes, sir.
I hear you, but that is not what I said. And I understand exactly what you are saying, but that's not what I said. How do we start? Kineidwe, you are at the beginning. I mean, you are at the end. For those who don't understand, I need them to be able to follow. Gineidwe, that's why I'm saying I understand what you are saying, but what you are saying is already at the end. You are already at the solution. Do you get me?
Yes, sir.
But now, if everybody wrote this system of equations correctly in matrix form, you will realize that what I said, in order to solve a system of equations, try as hard as you can to make the leading coefficient to be 1. Okay. And then in this case, the leading coefficient, what is the leading coefficient in this case? Umaira, what is the leading coefficient? Is 1. Thank you, Princess. Then, what are the entries below the leading coefficient?
0.
Do we agree? Everybody?
Yes, sir.
Yes, yes.
Yes, sir.
All of you, can you all see that below the leading 1, we have got zeros?
Yes, sir.
Yes, yes.
Yes.
Thank you. So now,
Yes, sir.
that is what we needed. That is what we should have had. That is what we should have solved. We should have solved the system in such a way that we have 0, we have those 2 zeros. But in this case, those zeros are already there. Now look at the second row. What is the leading entry in the second row?
3.
What?
2.
Sorry?
2.
3.
No.
It's
3.
2.
It's 3.
2. 2.
Wait, sir. Can you please repeat the question?
What is the leading entry in the second row?
3.
3.
Wait, isn't
Again,
3?
in a choir, like in church, in a choral form.
3.
We agree it is 3. Yes.
Yes,
Now,
I
yeah.
agree.
it's 3. We all agree, ne? Yes,
Yes.
we all agree.
Yes.
Thank you. Now, what is the number? 3 is the leading entry in the second row. Now, what is it that what do we expect the number below 3 to be?
0.
0.
In the second row. Do we agree?
Yes.
Is it 0 now?
Yes.
Yes, it's 0.
Thank you. Now,
Yes, sir.
now, if we all agree that it is then 0, now let's start to talk. How many unknowns are in this equation? I mean, in this system of equations?
5.
5.
5.
5 unknowns. Thank you. Do we all agree on that one?
Yes.
Yes.
How many equations?
Yes.
3.
3.
3.
3 equations. So now we have got more unknowns, less number of equations than what we expect. We expect this system to have infinitely many solutions. Now, in that case, this is what we do. From the third row, which variable is leading in the third row?
X3.
x3. So we'll have x3 is equals to minus 7x4
plus 1.
plus 1. Do we agree?
Yes, sir.
Yes.
Do we all
Yes,
agree?
sir. Yes, sir.
Thank you.
Yes, sir.
If we all agree, now look at that matrix the way it is. In the first row, which variable is leading?
x1.
Thank you. In the second row, which variable is leading?
x2.
In the third row, which variable is leading?
x3.
x3. Thank you. Now, this is how we solve this type of equations. x1, x2, x3 are the leading variables. For x4 and x5, which are non-leading, you can choose them to be any variable that you want. Did you get that? Should I repeat? Yes, Bosiso. Should I repeat?
Sir,
Yes.
in my attempt to solving the matrix, and sir, I said let x5 to be t and x4 to be s, where s and t are elements of real numbers.
Please come back again. You said?
I said let x5 and x4 to be s and t, where s and t are elements of real numbers.
Slowly, not that fast. x4,
Okay.
what is x4? x4?
x4, I said let x4 to be s.
Okay.
And
wait
x5
there.
to be t.
No, slowly. x4 is s. Yes,
Okay.
thank you. x5?
x5 is t.
T. Yes.
Yes.
Now, continue.
Where t and s are elements of real numbers.
Okay. Please tell them.
Tell them why I said that, sir.
What you just told me.
Oh, okay. Okay,
Yes.
I hope everybody's listening. I said my x4 is equals to s. And my x5 is equals to t. And where t and s are elements of real numbers, meaning that t and s can be any real number. Since we said our matrix has infinitely many solutions, that's why t and s fit in the position of being real numbers. Yeah.
Ask them whether they did understand what you just said.
Okay. Can you have a pen and paper and write let x5 equal t, x4 equal s, where t and s are elements of real numbers.
Now, what you just said, my brother, boils down to what I said, to say x1, x2, and x3 are leading variables. x4 and x5 are non-leading variables. They can be chosen to be any variable, which can be, again, chosen to be any number. Then we said we did let x4 to be s, according to Sibusiso. And then we said, no, x5 equals to t, okay? Then from this system, from this matrix that we are having, Magwena, then what will x3 be?
Oh, according to this matrix, I think it's gonna be x3 will be 1.
Why?
I'm not sure if I'm right or wrong.
So,
Why 1? Yes, someone is talking.
X3 is equal to 1 minus 7s, I think.
Is it Lerato?
Yes.
X3.
Yeah.
Okay. M1 Lerato, what are you saying? X3 will be
X3
equals to
1 minus 7s.
1 minus 7s.
Yes.
Okay, Lerato. Let's look at this matrix that we are having, okay? Let's look at the third row. From the third row, we have got x3 equals to minus 7x4. Do we agree?
Yes.
Minus x3 equals to minus 7x4. Do we agree?
Only
Or did I
minus
not copy correctly? Or did I? Or maybe I copied it incorrectly. Let me check.
Yeah. So I think he's.
It's for me when I work the thing out, my x3 was 0. I don't know how, but I got x3 is equals to 0. Then my x4 was equals to 1/7. Then the rest I just couldn't really do.
No, people, no. Okay, we all agree that this, in the last row, we have got 001701. We all agree on that one, né?
Yes.
Yes.
We all agree on
Yeah.
that one. That's the third row. Then, from that third row, that means x3 is equals to, you take that 7 to the other side of the equation. So we have, from that third row, we have got x3 is equals to minus 7x4, because x5 is 0 there. And then we've got 1 on the other side. That's why we've got x3 is equals to minus 7x4 plus 1. Any disagreement on that one? Or who doesn't see it? What I'm just asking, I'm saying from the system, from this system of equations, the matrix that we get, in the last row, we end up having 001701. Do we agree? Yes or no?
Yes.
Do we agree? Okay. If we agree, then what we notice from that last row, which is the third row, we notice that x3,
Yes.
x3 is equals to minus 7x4 plus 1. Do we agree?
Yes.
Yes.
Thank you. Then, if we agree, we already know what x5 is. We said x5, we did let it to be t. Now x4 was let to be s. Now we know what x3 is. x3 is minus 7x4 plus 1. In the place of x4, we put s. Do we agree?
Yes, we agree.
Yeah.
Thank you. Now we go to the second. We go to the second row. From the second row, we have got x2.
Yes.
Now x2. x2. Let's see. It is 3x2. 3x2 is equal to minus x3 plus x5 plus 2. Do we agree?
Minus x5.
Therefore, x2 is equals to minus 1/3 x3 plus 1/3 x5 plus 2. Do we agree? I repeat, x2 will be equals to minus 1/3 x3 plus 1/3 x5 plus 2. Are we in agreement? That is from the second row.
Yes.
If we are in agreement, then we know what x3 is. X3 will be substituted by what? By minus 7s plus 1. Do we agree? Where we see X3, we'll put minus 7s plus 1. And then plus 1 over 3, X5 we know is T. We'll put a T there, then plus 2. We together? Abdul, I'll be with you. As well as Vuyo. Do we agree on X2? Now, from the first row, then we will have X1 equals to negative 2X2 plus X4 minus X5 plus 1. Do we agree? From the
Yes.
first row, X1 will be equals to minus 2X2 plus X4 minus X5 plus 1.
Yes.
If we agree, then for X2, you will substitute with what we already found in terms of S and T. You will put there multiply by minus 2. We know that X4 is S. We know that X5 is T. Then from there, we will have our system in terms of X1, X2, X3, X4 equals to. Our solution then will be in terms of the S and the T. Are you still with me or are you lost?
I'm still with you.
Thank you, Lerato. Is it only Lerato who is with me up to so far?
No, I'm still with you.
With you,
no,
still
sir.
with.
I have this question. Since we say if we can have less equation than the unknowns, we say it's if infinitely many solutions, isn't it?
We say the system has infinitely many solutions.
Then is it always the case that we have to replace the other unknowns by the parameters, because we can also have the number which is equals the other number which they are the same. Then we can also say that is infinitely many solutions. I mean to say, we can also have numbers which they are equal. The coefficient of the unknown can be equals to the constant. Then we can say that is infinitely many solution for the matrix.
Who is talking? Is it Vuyo?
It's Vuyo, sir.
Vuyo. Vuyo. This is what we are saying. For all the non-leading variables, you are at liberty to choose them to be anything. That is what I said. It will, if you are bringing in numbers, then that is up to you. But it's up to you whichever numbers that you decide to choose. But the non-leading variables can be chosen to be anything.
All right, sir. Thank you, sir.
I don't know which numbers you will choose or whichever variables that you will choose, but that is up to you. And what I'm just trying to say is to say all the non-leading variables can be chosen to be anything. Now, did anyone understand the way we solved this exercise? It's an exercise, many unknowns, less more unknowns, less equations, where the non-leading variables are chosen to be anything or arbitrary numbers. In simple terms, can choose them to be anything. Was it clear to everybody? Can we step off it?
Yes.
Thank you.
So,
Yes, someone is talking.
so we use substitution to solve to solve for x1, x2, x3, right? Is there
We
any
use
way?
substitution in
Yes.
terms of
Yes,
let's say in this exercise.
yes, it's for this particular one.
Yes.
Right. Yes. So is there any way to resolve that problem using row operations only? Or no, we must use substitution?
Is it good one?
Yes, sir.
Okay. Are you saying in the situation where we've got many unknowns and less number of equations, is there any other way of solving the system? Is that your
Using
question?
particularly row operations, must we, or is the only way to use substitution?
Okay, hang on. Let me put it in this way.
Okay.
In this exercise, good one, we were just lucky. Okay, because from the, let me project this system. From this system, when you write it in matrix form, we realize that below the leading one, we had zeros, okay?
Yes.
And then we even had a 0 below the leading entry in the second row.
Yes.
Had we not had those zeros, then we would have solved this system in order to get these zeros. We would end up being where we are.
Yes.
Okay.
That is what I'm saying. In this case, we were just fortunate to have those zeros below the leading coefficients in the first row and then even in the second row.
Yes, I was actually just asking just to make sure that there won't come a time where we get something like this or a question like this, like exercise C, and then we are restricted within the instructions to only use row operations and not substitution. So yeah, I understand according to your response, sir.
Okay, thank you. If we are all okay, let's continue. Now, Gaussian elimination, solving the system by Gauss-Jordan elimination. Is there any confusion, or can anyone explain this in simple terms, particularly Gauss-Jordan elimination? In a simple language that everybody will understand. Anyone?
Sir.
Yes, is it Lerato?
Yes, sir.
Yes, my brother.
Gauss-Jordan elimination. It's like when you have zeros above and below the pivot leading ones.
Please repeat that.
Is when you have zeros above and below the leading ones.
Is that the way you can explain to us? Is that the simplest way that you can explain it to us?
Yeah, for me, this is the simplest way. Okay, the Gauss-Jordan elimination is the one whereby the matrix only has leading ones.
Yes. Now, Lerato, based on what you just said, né? remember, oh, were you with us in the session that we had during the day, in the afternoon?
No, I was not there.
Okay, and it's a pity that person who asked that question is not with us here. You see, now this is the challenge that we are having with the problem who are not consistent in terms of attending. Someone asked the very same question. Then that's why, if you remember the exercise, the first exercise that we started with was to explain the values that we found after writing the matrix in Gauss-Jordan elimination. I allowed someone to use the word identity matrix, if you still remember.
Yeah, at the beginning.
At the very beginning, because I needed us to finish up that exercise. So by backward substitution, we got the very same answers as using Gauss-Jordan elimination. But in terms of Gauss-Jordan elimination, you only need to have all those ones on the main diagonal and zeros above and below, as you just mentioned. Please ask your colleagues whether they follow what you just said or not. Or what has to be done, what needs to be done when we are requested to solve the system by using Gauss-Jordan elimination. Hey, Abdul. Yeah. Abdul.
Yes, I'm following, and if I'm to add on to maybe what I had, there is a few procedures that are involved when it comes to the Gauss-Jordan elimination. And mainly speaking, the first step would be the forward substitution, then the backward. Forward first, then backward after. So that's information I could add on to what has been shared already.
Thank you. Now, let me thank you all for your contribution. Now, let's talk about this system. Like in church, in chorale form. How many unknowns do we have in here?
6.
6 unknowns. And how many equations?
4.
4.
4. Now, this is the situation that we are facing. We are now having more unknowns and less number of equations. Do we agree?
Yes.
Yes.
Okay. If we all agree, then in a choir form, then what kind of solution then do we expect?
Infinite.
We expect to have infinitely many solutions. Do we agree?
Yes.
Yes.
Yes, sir.
Thank you. Now individually, I'm asking you to solve this system as I'm also solving it myself. In choir form, we agreed it will have infinitely many solutions. Now, we are individually solving the system using Gauss-Jordan elimination as it has been explained to us. And then we all agreed that we understand.
Sir.
Yes.
Is it okay to rearrange the rows after you have found the leading ones and everything? Or you must do it before finding them?
Okay, let me say this, which is something that I forgot to say. In the process of solving matrices, you can interchange rows and columns, but only once. Are we together, Lorado? Only
Yes,
once. You can interchange rows, not part of a row. You can interchange rows. When I'm saying a row, you interchange rows. You are interchanging entire rows. And you can also interchange columns, not part of a column, but the entire columns. Meaning you can swap them just like that, but only once. Am I clear, Lerato?
Yes, sir.
Thank you. Please make sure that from the system of equations, you have the correct matrix. Because if it is different, you will obviously have different answers.
Sir, like, is it fine, like, if only like the first row are the one that have like the leading ones, and the last two rows they have other constant values?
Please come back again with a question. Is it okay if
The first four columns, they're in
the first
Gauss,
columns?
they're in Gauss-Jordan. The last two columns, they have other constant numbers.
Okay, now, according to the interpretation or the explanation that you have given us, that means everything on top of those ones should be zeros, meaning we need to have ones on the main diagonal. And then with all the entries below the ones on the main diagonal being zeros, and then above them being zeros. Is that not what you said?
That's what I said.
Yes. So that is what we are striving for.
Okay.
Have I answered you?
Yes, you have answered me.
Is there something strange that you came across while solving this system? Or something interesting? No, let me say something interesting.
I got a row of zeros.
Which row? Row number?
Third row.
Third row. Alison, which row did you get to be an entire? Did you get it to be an entire row of zeros?
It was the third row, and then I swapped it.
Alison, you can only swap rows and columns only at the beginning, not in the process of solving.
Oh, well, I got it in the third row.
Oh, okay, thank you. That's where we got it. What are you saying?
For my first row, like horizontally, where I'm at, it's 1, 3, -2, 0, 2, 0, 0.
Second row?
It's 0, 0, 1, 2, 0, 0, 0.
Third row?
0, 0, 0, 0, 0, 1, and 1/3. Not sure about it. And then the last row is zeros only.
There is no way that the last row can be zeros. We have zeros in the third row.
Don't we swap? Don't they
Not
go?
here. No, that's what I said. We only interchange rows and columns at the beginning, not in the process of solving a system.
Oh. Oh. Then that means I'm wrong.
Now, hello, yes.
Yes, on my case, I swapped at the beginning, and then my last rows were zeros.
Your last row were zeros.
But I swapped at the beginning.
Okay, that is what is acceptable. That one is acceptable. We only swap at the beginning, not in the middle of solving the system of equations. We swap rows and columns only at the beginning.
Sir, I also have zeros on the last row. So I don't understand when you're saying it has to be on that row. And in that, if I have zeros on the last row, that means I have on the third row, it gives me x6 is equals to 1/3. And then I proceed with substitution up until I get all the other values.
So
yes, I'm listening.
Sorry about that.
Then you and I disagree then.
No, I'm not. I'm not disagreeing with you. I'm just confused. That's all. But I understand when you say we exchange in the beginning. So if you don't, will you still get the same answer?
Yes.
Okay, then.
Yes.
All right.
A row of zeros is the third row. Now,
yeah.
Let's talk about this row of zeros. What is this row of zeros telling us? Let me emphasize, it is not the fourth row. Those zeros must be on the third row. Now, I need to emphasize the importance of what this row of zeros is telling us. What is this entire row of zeros is saying to us?
No solution. No solution.
This time I disagree with you, Laurent. We disagree this time. Sbusiso?
It tells us, since it's in row 3, it tells us that X can be any solution, meaning that our system can have infinitely many solutions.
Just to add spice to what Sbusiso has just said, if you solve a system of equations and you end up having an entire row of zeros, that confirms.
It confirms that all the unknowns are equal.
Tanda Makosazana.
Yes, sir.
It confirms what?
All the unknowns are equal. X1, X2, X3, X4, X5, X6, they're equal to each other.
I disagree.
If they're also equals to 0.
I thought that child was giving you the correct answers. Now it looks like he or she is misleading. Okay, when we solve a system of equations and then in the process, then we end up having an entire row of zeros. This just confirms what we talked about at the beginning, to say this system has got infinitely many solutions. Are we together?
Yes, sir.
Thank you. Now,
Sir,
how will, yes?
Sir, I disagree with zeros on the third row. Zeros are on the fourth row.
Zeros are on the fourth row?
Yes, sir. All of them. And then on the third row, you have, let me see. So on the third row, you're going to have 5 zeros, 2, 4, 5 zeros, and then number 2, 4, 5. Number 6 is going to be 1. And then the last number is 1/3. Meaning where there's 1 is where it's supposed to be x6. And then it's going to give x6 equals to 1/3. And then you do some substitutions up until you get the others. Maybe tomorrow I'll have time to explain because now I'm on my way home, but yeah, I disagree. with what you're saying.
You disagree?
Yes, sir.
Sir,
Yes.
I also agree with the first part that the zeros that are on the last number, sir.
On the last row.
Yes, sir, because according to what I know, the rows from the beginning, when you see a matrix, for example, if row 4 has the leading one, you are supposed to interchange it to be row 1, according to the laws. And then on this matrix, there are 2 zeros. I think it's line 2 and line 3, which are supposed to be interchanged at the very beginning, which is line 3 and 4. Since line 3 has 2 zeros, we are forced to interchange it with line 4 at the beginning.
So you interchange rows 3 and 4?
At the beginning by force, because row 3 has 2 zeros.
Is that what you did? You interchange rows 3 and 4?
Yes, at the beginning.
At the beginning?
Yes.
And then you ended up with
row 4 of zeros.
Being all zeros?
Zeros, everything.
Yeah, that's interesting. I'm not saying what you are saying is not what we are not supposed to say. But what I'm just saying is to say, maybe I might have made a mistake here. Probably myself and even Alison. Maybe in our calculations, we may have made some mistakes somewhere, but I'm not sure where. This is a long exercise, which one needs to carefully needs to double check what he or she is doing. I don't know whether you get me or not on that one.
Yes.
I'm not disagreeing. Someone said an entire row of zeros on the 4th row. I don't disagree. But from where I'm sitting, I'm having an entire row of zeros on the 3rd row. So it's our task to agree.
On what, sir?
Hmm?
Onwards.
Onwards, yes. My request is that all of us, we will rework this exercise, okay? We'll rework this exercise. Next time when we meet, we'll be talking in one voice. Is that a fair request? Is that a fair request?
Very fair.
But this sorry, this example what is also on the textbook. I think I've seen. Yeah, it's also on the textbook. I just can't remember the page. But as I'm browsing through my notes, yeah, I did it when I was still studying. And yeah, they exchanged the rows. Like the row with entire zeros is at the bottom row.
Was the process of interchange, were those rows interchanged during the process of solving, or were they interchanged at the beginning?
At the beginning.
We only interchange at the beginning, not during the process of solving.
Okay.
Yes. So, Lerato, according to you, you interchange at the beginning, then you ended up having this last row of this row of zeros being the 4th row.
Yes.
I don't disagree. If that is what you did, then I don't disagree with you. That's why I'm saying all of us need to revisit this exercise so that we all get the very same thing. But the most important thing is that this system, what we need to do, our final system, our final matrix needs to be the same. And then from there, then we'll agree. We'll continue to agree on the fact that this system has got infinitely many solutions. I don't know whether I'm making sense or not.
Yes.
Let me request all of us to revisit this exercise. Do it again. I'll also redo it, and then we'll have to agree.
We should all have the same answer.
No problem.
And then next time when we meet, let me note it. It's this one. I need to avoid this thing of if one says no, the answer is 2, another one, let's say someone says the solution is 2, 3, 4, 5, and then the others then just follow suit without doing this. I'll think of a better way of being able to see everybody's answers to avoid that. So as to encourage all of us to work on these exercises. Can we then stop here?